Good evening. This session we're going to see on rectifiers and power supplies in electric circuits and electron devices subject. So let's quickly walk through how a voltage regulator fits into a power supply. Right? After the transformer and rectifier, the voltage still has ripples. A filter smoothens these ripples slightly, giving a steadier DC. Then the IC regulator comes in. It reduces the ripple to nearly zero, giving us a constant DC output for the load. So remember, filter smooths and regulates the stabilizes the voltage. And I just want to put a question in the chat box that which block provides the most stable output, a filter or a regulator? Type your answer in the chat box. Let's look at one of the simplest voltage regulator, the Zener diode regulator. This is perfect for low current power supplies. It uses a resistor to limit the current, a Zener diode and a reverse bias to clamp the voltage at a constant level, maybe typically in the range of 4.7 to 5.1. When the input exceeds the Zener voltage, it maintains fixed output by conducting in reverse. It's cheap and effective for small circuits. Let's briefly explore the two key types of voltage regulation in power supply. First, line regulation ensures a constant output voltage even if the input voltage changes. Second, the load regulations keeps the output stable when the load or current demand changes. Both are crucial for protecting sensitive electronic devices. Thinking of it like cruise control for voltage, steady no matter the terrain, right? So I just want to put another question that which regulation responds to changes in load, right? So I do request you all to type your answer in the chat. Let's understand what happens when the input voltage to a regulator varies. This is where line regulation comes in. Line regulation ensures the output voltage stays constant even if the input voltage increases or decreases. As shown in the diagram, whether the input moves up or down, the output meter barely shifts thanks to the regulator. This keeps your device safe and stable. Let's now look at how the voltage regulators handle changes in load. This is called load regulation. As shown here, when the load resistance, right, as it changes or increases the current, a good voltage regulator ensures the output voltage and makes the voltage constant. That's the essence of load regulation, maintaining the output despite varying the loading conditions. So this might protect the devices from voltage dips during sudden load changes. The two main types of voltage regulators are linear and switching. Under linear regulators, we have series regulator connected in series with load, shunt regulator connected in parallel with load. Switching regulators, on the other hand, uses high frequency switching for better efficiency. Both have different roles based on the precision and efficiency, right? So I just want to put another question. Which type do you think is more efficient, linear or switching? Type it in chat. Now explore how a series regulator circuit maintains a steady output voltage. It uses three blocks. The control element is placed in series with load. A sample circuit senses the output voltage changes. An error detector compares this with the reference and adjusts the control element to maintain the stability. This feedback loop ensures the precision of the regulation. We'll have a quick look at how op-amp series voltage regulator works. It's a smart way to get a stable voltage, right? So in this circuit, op-amp compares the reference voltage from the Zener diode with a sample from the output. If there's any difference, it adjusts the transistor Q1, the control element, to correct the output voltage. This keeps the output steady even if the input or the load changes. So the op-amp acts like a brain, sensing, comparing and adjusting in the real time. The shunt regulator is quite different way to control the voltage in circuit. In this setup, the control element pulls some different away from the load. If the output voltage changes due to load variation, the sampling circuit senses it and sends a signal to the comparator. This feedback helps control how much current is shunted, keeping the output voltage steady. Think of it like a traffic deviator, right? Diverter, sending excess current away to maintain the smooth to the load. An op-amp shunt regulator works to control the voltage using a simple feedback setup. This uses a Zener diode to set as a reference voltage. Op-amp compares with this sample of the output. If the output rises, the op-amp drives the transistor Q1 to conduct more, deviating the current through it and lowering the output. This keeps the load voltage steady. The most efficient voltage regulator can be termed as the switching regulator. Unlike linear regulator, switching regulator turns the transistor on and off rapidly, sending power in pulses. These pulses are then filtered to give smooth DC output. Because it's not always conducting, it wastes less power and is ideal for battery power devices. So switching regulators offers high efficiency and compact in design. Let's talk about something very common in circuits. It is IC voltage regulator. These voltage regulators are available as tiny chips and include everything inside, like reference source, comparator, amplifier, control device, overload protection. They come in both linear and switching types and usually have three terminals: input, output, and ground. So IC regulators are compact, reliable, and easy to use. One of the most commonly used components, it is the fixed voltage regulator. This regulator takes an unregulated DC input and gives a constant DC output. Right? The popular 78XX series has three pins, one for input, one for output, and one for ground. For example, 7805 gives a fixed 5 plus volt of DC. It's simple, reliable, and great for powering the microcontrollers. Just like 78XX gives positive voltage, let's now look at 79XX series for negative voltages. The 79XX regulators also have three pins and give a fixed negative output voltage. They work with same as 78XX regulator, but with different pin configuration are used in circuits that they need a negative supply, like a dual power op-amp circuits. So if 7805 gives plus 5 volt, 7905 gives a minus 5 volt. Simple, am I right? So not all the circuits fixed voltage. That's with the adjustable voltage regulators comes in, right? So LM317 is a popular adjustable regulator. By changing the values of two resistor, we can set the output voltage anywhere from 1.2 to 37 volt. This flexibility makes it perfect for projects that need custom voltage levels. So think of LM317 as a customizable power supply on a chip. I just want to put a quick question. What is the lowest voltage you can get from LM317? Type it in the chat. Thanks for watching this video. I'll catch you in the upcoming session. Thank you.